Okay, so in this video we're going to look at another example using the law of cosines, except this time we're solving a triangle with given three sides. So in this case we have the side, side, side case, and so the law of cosines we're going to use involves the angle form. So the angle, the cosine of an angle equals the sides. Okay, so let's see. Now, just what I want to do here is I want to find the angle that corresponds to the smaller side. So we're going to find A first. And remember, the reason for doing this is if any angle is going to be obtuse, it's going to be the larger one. So I know that when I find angle A, it should not be obtuse. All right, so it'll be just that one. So let's do that. Okay, so we'll start with A. So we know that the cosine of A is going to be equal to A squared minus B squared minus C squared divided by negative 2BC. Okay, so that's our formula for the law of cosines when we're given three sides. This is one of them. Okay, so then we put the information in. So it's going to be 5 squared minus 7 squared minus 9 squared. Divide that by negative 2 times 7 and 9. Okay, and that's cosine A. And then we take the cosine inverse of that. So A equals the cosine inverse. And we get 5 squared minus 7 squared minus 9 squared all over negative 2 times 7 times 9. We run that into our calculator and we get approximately 33.6 degrees. So now that we have A, now we're ready to find the other two angles. So what we're going to do is we're going to find the angles going corresponding to the sides in increasing order. So I'm going to find angle B next. So let's find B. Okay, and I'm going to use the law of sines to do this. So I know that the sine of B over B equals the sine of A, since that's the angle that we found previously. So we're forced to use that over side A. Okay, so we have that the sine of B is equal to, let's see, 7 times the sine of 33.6 degrees over side A, which was 5. And so now B is equal to the sine inverse of that. And so B is going to be approximately, let's see here, we run that into the calculator, we get approximately 50.8. Okay, now remember, every time we use the law of sines to find an angle, we always have to consider two solutions. Now, if we look here at this line, sine of B equals 7 times the sine of 33.6 over 5, we're saying that the sine of some angle is equal to a positive number. We know that sine is positive in quadrants 1 and 2. So it's possible that B is in quadrant 1 or B is in quadrant 2. So this is like B, and this is like my B prime, like my alternate solution. Now, since B is not the largest side, there's no way that B can actually be this angle here in quadrant 2, because a triangle can have at most one obtuse angle. So, for example, if I even considered it, let's say B prime equal to 180 minus 50.8, right? Because then this B here would be like my reference, and so my reference would be here, and so to find B prime, we take 180 minus B, minus the reference. And so if we did that, then we would get that that would possibly be, let's see, approximately 129.2 degrees. Now this is impossible once again because B can't be obtuse. B is not the largest side. If any angle is going to be obtuse, it's going to be angle C because side C is the largest side. Okay, so this solution here we're going to drop out. Okay, and so now the last thing to do is to find angle C. But that's no problem because we already have the other two angles. So C is just going to be 180 minus the sum of the first two, which was 33.6 plus 50.8. And when we run this through the calculator, just adding those up, we get that C is going to be 95.6 degrees. Okay, and that's how we can find the missing parts. And let's just go back up to our original, fill in. So we said this was 95.6. This was 50.8. Okay, and just checking our information. So we have that the largest side is 9, and that corresponds to the largest angle. The in between, the middle side, which was 7, corresponds to the middle angle, and the smallest side, 5, corresponds to the smallest angle, A. All right, and that is how we find the missing parts for a side-side-side triangle.